Hi students, this is lesson 6.4 and it's going to focus on the composition of functions. So you most likely have worked on this previously in an Algebra 2 course, and we are going to go ahead and expand upon that knowledge, but even if it was a little shaky back then, we're going to do a little review here so it shouldn't be too bad. Our goals here are to find the composition of functions algebraically and determine their domain, identify two functions that make up a composed function, and evaluate a composite function given an equation, a table, or a graph. So here is our definition. So composition of functions. What this is basically telling us is we're going to use the output of one function as the input of the other function. So if we look at this notation, g of x is really what the output would be. And we're using that as an input into function f. And we're going to, of course, do several examples of these to practice. So you may see a couple of different things. This looks like fog. There's a little open circle here. It does not mean we're multiplying them. We're going to say f of g. So that's, if we see that, that's what that means. And it's equivalent to f of g of x. So I went ahead and wrote down the way that you're going to say these. So make sure you practice that and you understand what that notation means. Okay, so we're going to go ahead and compose the function and we're going to evaluate. So we're going to find f of g of x. And we're given f of x and g of x. Of course, please pause, copy this down in your notes, and take as long as you'd like. So f of g of x. We're going to go ahead and g of x is x minus 3. So I'm going to use that as the input. So now when I look at function f, where do I put the input? Right here, in for x. So we're going to say that this is the input squared. The input squared. Now, quick reminder, remember, and you don't have to use the area model, but please remember this is x minus 3 times itself. So you should end up getting x squared minus 6x plus 9 when all is said and done. Now the next part of this is asking us to evaluate. So they're saying, hey, what happens when x is 5? What am I getting as an output? So we can say f of g of 5. We can go ahead and plug in 5 into the function g. That would be 5 minus 3. And then, of course, we're putting that whole thing into function f, which is input squared. Now, we've already composed this. Take a look right here. So that's where you see this. Okay, so nothing too crazy. All right, so this would equal then 2 squared, which would equal 4. Now, the other way we can do this, is we can go ahead and leave the f there. So we can say f of g of 5 equals f of 5 minus 3, which is f of 2, and then we would say, okay, the function f is the input squared. 2 squared is 4. Doesn't matter, you can do either way. Okay. Now, this is going to do the same thing. We're going to go ahead and practice this. Given the same two functions, we're going to compose them 4 different ways. So again, make sure you're writing this stuff down, and we'll go ahead and work on this. So f of g of x. G of x is the input. So we're going to input g of x into the input for f. So this is going to be the square root of the square root of that 2 minus x. Make sure that that's under the radical. So this is actually what this would be. And then we could also write this. We know that this is 2 minus x to the 1/2. All to the 1/2 if we go ahead and write it with exponential rational exponents there. So this is really 2 minus x to the 1/4, or the 4th root of 2 minus x. So we can go ahead and clean that up as best we can. So now we're going to go ahead and we're going to do this in a different direction. Let me just change colors to separate this a little. G of f of x. So now this is going to become the input, f of x. You can tell because it's inside right here. We're going to put this into the function g in place of x. So it's the square root of 2 minus the input. What's the input? Square root of x. Okay, now at this point, you might be like, oh, well, let's go ahead and do the 1/2 and everything else. For the exponents, this is not going to work out quite as cleanly because the entire inside is not part of a radical like this one was. Okay, so this one we can just leave as is, and that is simplified. Okay, now we're gonna go ahead and input a function into itself. So f of x is going to be put into the function f. So the function f says take the square root of the input. What's the input? Oh, it's the square root of x. And now we know this is actually going to be the same as the 4th root of x, same reason as the first one in blue. And the last one is g of x. So we have the function g, and it says take the square root of 2 minus the input. Okay, the input is g of x. The square root of 2 minus the input, which is right here. Again, we're kind of stuck at this point where there's not much that we can simplify. So that's just a little practice on composing functions. Now, decomposing functions, this might be something new for most of you, but this is where we're going to go ahead and play detective and figure out what are the original 2 functions that were used. Sometimes there'll be more than one answer, which is totally fine, and these examples actually will have that. So this is saying, hey, h of x is the same as f of g of x. What do you think f of x and g of x are? Now, you're never allowed to do this because that's going to be way too easy. So it's not that that's wrong, but we're going to go ahead and try to make it a little bit more interesting. Okay, so when I look at this, I see, hey, couldn't we input this? Couldn't that be our input? So right away I'm thinking, what if g of x is x squared plus 6? What would the outer function be for f of x? That would be the natural log of x. Okay, so what happened here is we said, hey, let's let, because remember this is, f of g of x. So the input, we're saying, hey, let's make this be the input, and let's put it in place of x in function f. Natural log of the input is natural log of x squared plus 6. Okay, now, there's other ways to do this, and there may be more than the 2 I'm just going to show you, but I'll start with these 2. So what if we said the input was x squared? Okay, so I said it can't be x, but it can be x squared, it can be natural log of x, that's fine. So what would the outer function be? So this is the inner function. The outer function would have to be the natural log of the input plus 6. And so again, what is this telling me? This is saying if it's f of g of x, this is the input. We're putting it in place of the input in f of x. Okay, let's take a look at a couple more of these decomposition. So this is the h of x is the cube root of 1 minus e to the x. Same thing here. We're going to go ahead. We know this is the definition. Let's think about what could the input be into the outer function. So the inner function could be 1 minus e to the x. And then the outer function could be the cube root of x. So again, we would say, does this make sense? We would take this and plug it in here for x, and yeah, that would give me the same thing we started with. Okay, or let's see, what else could we do here? We could say the inner function is just e to the x. Okay, and so what would the outer function be? That would be the cube root of 1 minus x. Let's see if this makes sense. Here's that inner function. We're going to put it right in here, and then we'll match up with our h of x. Please don't forget to pause and give some of this some thought and some trying on your own too. Okay, last decomposition. So h of x is the same equals f of g of x, so same definition here. Let's think about our inner function g of x. So the inner function could be x to the fourth plus 5. The outer function could be the absolute value of x. Again, let's do a quick sanity check. If that's the inner function, this says take the absolute value of the input, and that would match. Okay, so we'd be good there. The other way that we could try to do this is we could say, let's see, what could we say for our inner function? We could say just x to the fourth, and then the outer function would be the absolute value of the input plus 5. And then once again, this would be plugged into here, and we always want to match whatever we started with when we're decomposing. Okay, so the last little bit we're going to talk about is domain. So these, again, this should be mostly review. We're looking at which values are we allowed to use. So when we look at this first f of x, we're looking at the square root of 4 minus x. What do we know that we don't want under the radical? We don't want, and since it's an even root, we don't want to have a negative under the radical. So I'm going to set this discriminant here equal to 0 and solve, and 4 is equal to x. Now this is how I would go ahead and prove it. I would test the two regions. I'd say, what if I said I plugged in a 5? Well, 4 minus 5 is a negative, right? We have square root of 4 minus 5, which equals the square root of negative 1. We can't use that part. Let's make sure we can use the other part. So I'll say test x equals 0. 4 minus 0, that's going to be 2. That works. So our domain is going to be from negative infinity up to 4. And I am allowed to use 4. Because if I put 4 minus 4 and take the square root, I get 0. That works fine. Okay, and also remember for this graph, that might be something else to think about, is that the graph here, so we're going to be at 1, 2, 3, 4. Think about where you're starting. You're starting here, right? And then if you start plugging in other values, so if we plugged in 0 and we got 2, we're going to look something like this. Okay, let's take a look at the absolute value. Now in this case, there's nothing that is troubling us. We can use any value we want, positive, negative. We're always going to get a good output. Everything is fine. No undefined values. So in this case, negative infinity to infinity. And again, if you think of your graph for this, we'd be at negative 2. Opening up, all the values work fine. For the next one, we do have a troublemaker because remember, we can't divide by 0. Okay, so let's go ahead and set that denominator equal to 0 to find out where that spot is. It's at 5. If I plug in 5, I have a big problem. I can't do that. Okay, so I know right away that's an open circle. What if I plug in 6? That's fine. What if I plug in 4? That's fine too. It's going to be a negative number. It doesn't matter. So the domain here is everything union here in between. But that's to show we cannot include 5. That's the only number that's off limits for the domain. Now what about this next one? The natural log of x minus 6. So the natural log, we know that we're not going to take what for this? We can't have the natural log of 0 or lower than 0, right? So let's go ahead and do the same thing. Let me switch colors here. Okay, let's do x minus 6 equals 0. And let's look at this number line again. Okay, so we have 6. We're not going to want to use that. Okay, and if we plugged in, let's say we plugged in a 7, would that work? Natural log of 1, yeah, that would be fine. But if we plug in a 5, we're going to have natural log of a negative, which we can't use. So the domain here is going to be 6 to infinity. Okay, 6 to infinity. So that will be our domain for this one. All right, now this last thing, I think this is the last. Okay, 2 more little baby problems, and then we're all done. Okay, so what we're going to do is we're going to do a composition, and then we're going to show the domain for the composition. So this is the next level up. So we have g of x. We're looking at these 2 functions. We already said for these 2 functions from the last, and you'll have this in your notes still, same functions, we could use negative infinity to 4, and this was all real numbers. So we've already done that part. Now let's go ahead and compose. This g of x is the input. The function f says take the square root of 4 minus the input. Okay. So from here, what we can do is we can go ahead and think about what values are we going to have an issue with. Remember, for this, we need to have the discriminant. Let's just say, let's do it this way. Any value under an even root or radical must be greater than or equal to 0. Okay, so that's what I would take a look at. So let's go ahead and set that equal to 0. 4 minus the square root of x plus 2 equals 0. And let's go ahead and solve this. So I'm going to add the square root to both sides. And now this is saying something. If I take the absolute value, is going to be 4. So what does that something have to be? Let's think about absolute value. Well, absolute value of 4 is 4. Okay, so that's the guts here, could be 4. But guess what? The absolute value of negative 4 is also 4. So we have 2 different possibilities. So we're going to say that x plus 2 could be 4, but x plus 2 can also be negative 4. And that would work. So we get x equals 2 and x equals negative 6. So we're going to do this same idea of the number line. And this is how we're going to show negative 6 and 2. And we're going to test the 3 regions. So if we go ahead and we test x equals negative 7. Let's think about that. If we test x equals negative 7, it'll be the square root of 4 minus absolute value negative 7 plus 2, okay, which is going to be, let's see, that's 5. We'll get a negative 1 under there. Can't use that. Okay, no dice. Now let's test x equals 0. Okay, so we'll say that's the square root of 4 minus absolute value of 0 plus 2. And that would get us the absolute value of 4 take away 2, which is the absolute value of, or sorry, I keep saying absolute value, but now we are to the radical. So sorry. So it's the square root of 2, which does work. Okay, so far so good there. And let's look at our last region. So the last region, let's test x equals 3. So let's try to say the right words this time. The square root of 4 minus the absolute value of 3 plus 2. And I'm just plugging these numbers in. You can pick anything to test that's in the region. And this will be square root of 4 minus 5, which is square root of negative 1, which is not going to work. So what we're going to look at here is the domain. That's what we're trying to find, right? The domain of the composition is going to be from negative 6 up until 2. And we actually are allowed to use those. So I do need brackets, because if I put in negative 6 or 2, I will get the square root of 0, which is fine. Now, the only thing you need to be careful about is if you weren't allowed to use it in the input function, you can't use it in the composed function. Now, lucky for us at this point, we didn't have any restrictions. So that means this domain is the domain of the composition. Okay, last one. Thanks for hanging in here with me. So g of h of x. So here's your input. Here's the outer function. The outer function says it take the absolute value of the input plus 2. That's what we're doing. Okay, so the absolute value of the input, that's 1 over x minus 5 plus 2. Okay, now we've already talked about what these little domains are. Just for g of x, it was all real numbers. And for h of x, it was everything except for 5. We already did that previously. So now our job is to find out what's the domain of the composed function. Now remember, we were not allowed to use 5 in the input function. So no matter what, we can't use 5 in the composed function because it wasn't part of the players in the beginning. Okay, so where are the issues for this absolute value? The only thing that's really going to cause us a problem is this denominator cannot be 0. So this is the denominator cannot be 0. We're not going to divide by 0. So this is actually exactly the same as we did for just h of x. That's the only troublemaker we have. So it's going to be exactly the same as before, where if we plug it in here and here, we're fine, but we are not fine here. If we look at that, it would be just 1 over, let's say, I guess I'll put in 0 here and 6 here. So it'd be 0 minus 5 plus 2. And again, if you look at this, we don't even really care what the number is. We know we're going to get an output. So that's fine, okay? And then we go ahead and if we do keep going, we get negative 1/5 plus 2. And so that would be 1 4/5. And that's fine. And then over here, if we put a 6 in, we'd say 1 over 6 minus 5. And this is in the absolute value. And we'd get 1 over 1 is 1 plus 2, 3. The absolute value of 3 is just 3. So for the overall domain for this one, it's going to actually be exactly the same as h of x. So sometimes that will happen. And that's your final domain of the composed function. Okay, thanks for hanging in there, and I will be happy to answer all your questions in class, so make sure you make a good note of anything you're confused.